So let's kind of review a little bit of what you were supposed to do on Friday, which was finish the rest of the PowerPoints that were in the Friday folder. So here goes. We're going to go ahead and just start working the example out, and then we'll come back to all these details here. So today we're going to learn how to do, or we're going to redo a hypothesis test. So here's all the steps. Number one, according to a Pew Research Center, 35% of teens have some experience in dating or romantic relationships. If we take SRS stands for simple random sample. So if we take a simple random sample of 100 teens and find that only 25% of them have been in a relationship, do we have evidence to suggest that the true proportion has changed? So this question specifically asks for like the word changed instead of like increasing or decreasing. So because it asks for the word changed here, when we do our hypothesis, we're going to do a not equal sign. So let's go through the steps. Step one, you're supposed to define the parameter. Remember that your parameter is always like the P equals. And you can always just read the question to see what the P should be, but P should be the population proportion of teens who have experience in dating. So remember that we use the symbol P, just the regular letter P, and we write P equals true proportion of teens who have experience in dating. So that you would have to write there on your document. Well, actually, I think I wrote it down for you. Yeah. Okay. This next info here, you don't have to write that down all the time, but it helps if you do write it down. So according to the problem here, the 35% that's given first, that's how much the research center claims that's the true population of teens who have experience in dating. So that's what we're going to use as our P. We're going to use that as 0.35 because we believe that the true population of all teens who have experienced dating is 35%. So I'm writing down P equals 0.35. Next, the 25% that's given later, that 25% only applies to your sample of 100 teens that you took. So that's called a sample proportion, and we use a P hat for that. So again, this information is not required for you to write it down, but I think it's helpful, so I like to write it down. P hat equals 0.25 and the P equals 0.35. So that's always step one, to define your parameter, which I've done. Okay, now practice the hypothesis. Step two, state the null and alternative hypothesis. So I talked to you a little bit about it last Friday. You were supposed to finish the PowerPoint to practice writing hypotheses. But the first hypothesis that you write is the H sub 0. So that's called the null hypothesis. That's how you're supposed to write it, H with the subscript of 0 or O. And then you put P equals 0.35 because your hypotheses are always about the parameter P. And they always talk about the population parameter. So we're assuming that the research center is correct. And we're assuming that 35% of teens have experience in dating. So put P equals 0.35, and that's called the null hypothesis. Then you have to write the alternative. And for that one, you write H with the subscript of A. And the alternative is whatever the question's asking you. Like it wants to know if there's a difference or an increase or decrease or has it changed. Again, so it's just because it says the word just changed, and it doesn't give you a clear like increase or decrease direction, then we're going to do the not equal to. So we want to test to see if the proportion of teens who have experienced dating is any different than 35%. And it looks like it's decreased. It's only 25, but we're just going to put not equal to. So that is called step two, writing hypotheses. Step three is to check the conditions. We've already done those so many times. So I guess if you just read right there on the document there, the conditions are, problem says we have a random sample of teens. You're supposed to write that up. Surely 100 teens is less than 10% of the population of teens. I think the only one that really you want to practice is the large enough. So remember that for the large enough, when it comes to hypothesis test, you're supposed to check that N times P is at least 10. Let me highlight that. Okay. And then you're supposed to check that N times 1 minus P is at least 10. So go ahead and check that, I guess. And N would be your 100. So I'm going to do the 100. Remember, P should be your population proportion. So we're assuming that the P is the 35%. So don't use P hat. So we shouldn't be using 25%. We're going to be using 35. So clearly that and the complement, those are definitely at least 10. So then you have checked the appropriate conditions. If you have any questions at any moment, please let me know so I can pause my recording. Okay, so that's called check the conditions. And now let's practice the math again, the finding the test statistic, which is a z-score, and finding a p-value. So remember that to do the test statistic, there's a formula you're gonna have to memorize. So go ahead and practice writing the formula down so you can start memorizing it. And this is for your test on Friday. You have to have this memorized. So here's the formula. Z equals, this is a formula for your test statistic. Z equals P hat minus P divided by the standard deviation, which the standard deviation will be the square root of P times 1 minus P over the sample size. So once you have the formula memorized and written down, now you can start using substitution. Remember that the P hat is called the sample proportion. So in this sample, 25% of students have experience in dating. So that's 0.25 minus the true P, which we're assuming is 0.35. And then divided by the square root of 0.35. Let me make sure my math is right. Times 0.65. And then that should give you what I have there, negative 2.0. Let's just confirm. 0.35 times 0.65 over 100. Yep, negative 2.09. And then you can round to whatever, just on the test, just follow the directions. If it says round to 2 decimals, 3 decimals, make sure you round correctly, okay? So I think I did put some of these on the test, and these would be like fill in the blank. So you only have to type in the final answer. So Saina, because this is just online testing, I don't really make you show your work, or you don't have to show me your work. Technically, you should be showing your work. But on the test, all I need is just the answer, Saina. You'll just fill in the blank with negative 2.097. So that's called.
And
yeah.
How much do you want us to round to?
Oh, just follow the direct. Overall, like if it's for response and on the AP exam, it doesn't matter. You can round to 2, 3, 4 decimal places. But on the test, just because it grades it, just follow the directions. I think it'll ask you for 3 decimal places. So make sure you round to 3 decimal places.
Okay.
Yeah, just follow the directions. Okay, so there we go with the z-score or test statistic. Now let's practice the p-value thingy. Okay, with the p-value thing, it depends on remember, we're supposed to be doing like either greater than negative 2.09 or maybe less than negative 2.09. And that depends on the alternative hypothesis. Like if this was a greater than symbol, then we would be doing greater than negative 2.09. Or if this was a less than symbol, we would be doing less than negative 2.09, like I showed you on Friday. However, this is a not equal to symbol. So here's what you're going to have to do. So for the not equal to symbol, you're going to have to do the probability that z is less than negative 2.09, less than. So we're using the less than symbol, but we're going to multiply by 2. And the reason why you have to multiply by 2 is because when you have like a not equal to, you're actually testing both. You're testing to see if it's less than 35% or more than 35%. So the best way to do that is just find the probability that z is less than negative 2.097 and then just multiply it by 2. So I think, did I do my notes? No, okay, yeah. So go ahead and write that down on your notes for work so that you know if the alternative hypothesis is a not equal to symbol, you need to be multiplying finding your p-value and multiplying that number by 2. So I guess on your calculator, if you do a normal CDF, you want less than negative 2.09. So negative infinity is your lower bound. Your upper bound would be the negative 2.097. And then you're going to have to multiply it by 2. So I guess, where's my calculator? I can show you. So remember, you do menu, probability, distributions, normal CDF. You want less than negative 2.097. Always leave this mean as 0 and the standard deviation of 1 because that's how z-scores work. And then you have to multiply by 2 because you have a not equal to hypothesis or alternative. And that would be called your p-value. And so make sure you know how to do that because those are also on the test. Again, fill in the blank. Just read the directions. If it tells you to round to 3 decimal places, make sure you round to 3 decimal places. But that's how you find the p-value. And that's how you do the calculations of a hypothesis test. So practice doing these calculations. Practice writing hypotheses. Practice writing conditions and defining your parameter. Now, the hardest part is doing the interpretation of all these results. So we're going to have to interpret this p-value, 0.036. Again, it has to do with what we did on Friday. For starters, there is a wording recipe for interpreting the p-value. The wording recipe, it's on the PowerPoint from last Friday, so make sure you go back and look at that one. But basically, the wording recipe says that if HO is true, then the probability of observing the given statistic is p-value percent. So here's how you write it specifically for this example. You would say if HO, which was the P equals 0.35, so you would say if only equal to 35% of teens have experience in dating, so in other words, if HO is true, then the probability of observing the given statistic, and the given statistic here would be your sample, like 25% out of 100 who are in a relationship. The probability of observing the given statistic is only about 3.6%. So it's very, very small. So that means that HO is probably not right. And because remember I told you that anything less than 5%, you would say, okay, that's very, very small. So you reject the null and let's just one step at a time. Go ahead and write this down. If only 35% of teens have experience in dating, then the probability of observing the given statistic, which is the 25 out of 100 students who have experienced dating, is only about 3.6%. Okay, so I hope you looked at the stuff from Friday because it's about to get more confusing now. So I already told you that usually anything less than 5% is considered small enough. However, on Friday, you were supposed to go through a PowerPoint about something called a significance level. So if you read this question at the very top, it says with bolded letters there, it says, oh, the one on your thing says something different. Change it to 1%. Okay, so let's talk about this percentage stuff. And we're actually going to do both. Here, change this to a 1%. Okay. And I have the answer for both 1% and 5%. So for starters, let me tell you what this is. This is called a significance level. So here, we'll come back to this. Where is significance level? Here we go. And that's at the top of your notes. So a significance level is something that's given in the question that tells you, first, let me just read you. What is a significance level? At the top of your notes, it says, it is the probability that we will reject the null hypothesis, assuming that it was true. We use this Greek letter alpha, so it's a Greek letter A. We use alpha to denote the significance level. So if you ever see this Greek letter A called alpha, that's called the significance level. And it can be any value that you want, or usually the question will tell you what to use. It can be any value. The most common values that we use are 0.1, so 10%, 5%, or 1% significance level. Now, the most common is the 5%, and that's what we did on Friday. So anything that was 5% or less, we said, I reject the null hypothesis. So let me go back to my answer. Okay, on this one, I wanted you to do a 1% significance level. So let's practice using a 1% only. So here's what I mean. If you're using a 1% significance level, oh, and I think I should have kept going with this stuff. The significance level tells you whether to reject or not to reject the null hypothesis. So like we did on Friday, if your p-value is less than the significance level, then you will reject your null hypothesis. But if the p-value is greater than the significance level, you do not reject the null hypothesis. So again, let's finish that example. All right. we're going to use 1%. So we're going to say for your decision, because my p-value of 0.036 is greater than 1%, I do not reject the null hypothesis. So that's what I need you to write down for letter G. Based on your p-value, what is your null hypothesis? So you would say, because my p-value is more than 1%, I do not reject the null hypothesis. So that's what you would say for your decision. Because my p-value is more than the 1% that I wanted you to use, then I do not reject the null hypothesis. And then when it says the conclusion here, since I didn't reject the null hypothesis, then we don't have enough evidence that the alternative is true. Or in other words, there's not enough evidence that the proportion of teens who have experience in dating has changed. So I'll give you a minute to write it down using like the 1% significance level. So when you make your decision about rejecting or not rejecting the null hypothesis, it's supposed to be based on the significance level and not just 5%. On Friday, we just did 5% to make it easier, but from now on, you need to reject or not reject based on the significance level that is given. If there isn't a significance level given, then you can always just go with 5% by default. So give you a minute to write that and ask a question. If you have a question about it so far. Not yet. Just keep going. This next one you don't have to write down. I just wanted to show you. So what if I change the significance level to 5%? So like it was originally on your paper, but that was a typo. But anyway, if you change, if instead of using a 1%, if you change a 5%, then in that case, you would say, I do reject HO because that p-value of 0.036 is less than 5. That's not on your paper. You don't have to write it down. I just wanted you to see it. So rejecting the null hypothesis depends on the significance level. So here, if it is 5%, I would say my p-value of 0.036 is less than 5%. So I do reject the null, and there is evidence that the proportion has changed. And that just depends on what significance level you want to use or what the question is asking you. Okay, final thing about the chapter 19. And I kind of already went over it, but if your p-value is less than or equal to the significance level, you will reject the null hypothesis. Just make sure you check the significance level. If the p-value is greater than the significance level that is given, then you fail to reject the null hypothesis. If the problem doesn't give you a significance level, then assume 5%. Last thing about these decisions, you need to know that they're always about the null hypothesis. So you should always be rejecting the null or failing to reject the null. So your decision shouldn't be about the HA. They should not be about the alternative. They should always be about the null hypothesis. And final thing about the conclusion is that conclusions are always about the HA. Or in other words, they answer the question that's being asked. So this whole question was asking, has the proportion of teens that have experienced dating, has that changed? And that's what you're answering. Yes, we have evidence that it has changed, or no, we don't have evidence that it's changed. It just depends on your results. So that was a summary of chapter 19. I still need you to go back, and I recommend reading the chapter and go back and look at all the PowerPoints that I've given you for chapter 19. I think there's one more slide here. I already talked to you guys about the significance level. The other thing that you need to know from the PowerPoints on the last lesson Friday is something called statistically significant. So if you have your notes, it's right there at the top of your notes. Right here, statistically significant. You need to know what that means. And what that means is, again, with the p-value and the significance level, when you reject your null hypothesis, so in other words, when your p-value is less than or equal to the significance level and you reject the null, that's called statistically significant results. So if you ever see the question, are the results statistically significant? It's just asking you, in other words, did you reject the null hypothesis? So memorize that. And then I guess the opposite is true. If the p-value was greater than significance and you did not reject the null hypothesis, then that's called your results were not statistically significant. So make sure you know that definition of statistically significant. And we'll do one last example, and then I'll answer any questions. And if not, you can work on that review thing that's for a daily grade.
Can you go over that last part of the slide?
What's last part?
How large of a random sample?
Oh yeah, we're about to do that one. This one. Yeah. So this is the last one. Letter I. How large of a sample is required to obtain a margin of error that it's 0.03 with a 95% confidence interval? So this goes back a little bit to chapter 18. And here's how you need to solve these. You need to know the formula for the margin of error. So I wrote it down. You can go ahead and copy it down on your notes. The margin of error for a confidence interval is always margin of error equals Z star times the square root of P times 1 minus P over N. That's the formula for the margin of error. Now that you have the formula written down, you just start substituting values. According to letter I, you want the margin of error to be 3%, so 0.03. So that's what you're going to substitute for the margin of error, 0.03. 0.03. And then remember, I taught you on chapter 18 how to find the Z star when you're doing 95% confidence. You're supposed to be doing an inverse norm of 0.975 because you have to add the bottom tail, comma 0, comma 1. And then you do the square root of, okay, here in this formula, you're supposed to always use P. And according to this problem about the research center, we assume that P is 35%. Like we assume that 35% of teens have experience in dating. So that would be 0.35 times the complement over the sample size. And I did teach you how to solve that on the calculator with the LinSolve. If not, go watch the video again, or we can do it very quickly again. You're supposed to, where's my calculator? You're supposed to go to menu, algebra, numerical solve, type in the equation, 0.03 inverse norm of 0.975, comma 0, comma 1. And then we did times the square root of 0.35 times 0.65 over n. And then you have to put a comma in here or it won't work. So
Why are we using 35 and 65?
because so first of all, the answer is 971.01. So here you always want to use the true P, like the true population proportion. So according to this example, the true population proportion is 35% of
This
teens.
is the same question.
Yeah. Same question as it's just part I. But to clarify what Raj just asked, it's important. Like in the formulas, you're always supposed to use P if you know it in the question. Like if the problem is a continuation of something else, like if you know the true proportion, you're supposed to use P. If you don't know P, then you move on to like a P hat. Like maybe if you just have a sample proportion, P hat, use that. And finally, the one we did in class was if you don't know anything, either P nor the P hat, then the last resource is to use 0.5 times 0.5. And that's the one we did in class that one day because we didn't know P and we didn't know P hat. So I guess worst case scenario, if you don't know anything, then use 0.5 times 0.5. And these are all approximations, so they're all kind of right as long as you just show your work. So according to this, my n should have been 971.035, and you always want to round up because you can't have like 0.035 of a person, so 972 people. And that is how you do chapter 19 and all of chapter 19. I still strongly think you should read chapter 18 and 19 before your test. And if you have that book, practice like the odd exercises. The answers are in the back of the book. Okay, the next part is just where am I? Next part on your notes here. I need to show you, or I want to show you how to use the calculator to perform these hypothesis tests. The calculator has a function that can do these for you. And I just want to show you so that you know it. So number 2 on today's notes, it says, use the calculator to perform the above hypothesis test. Obviously, we already did it, so we know the answer. But here's how you use the calculator to do the, basically, we're about to redo number 1 here. Here's how you do it. On your calculators, you need to go find what's called a one proportion test. It's in there somewhere. You have to click Menu, Statistics. Wait, do all of you have a calculator? No. Okay. Menu. You need to practice it because it could be like time saving here. So Menu, Statistics. It's called Stat Test, number 7. Stat Test. Okay, these are all of the tests that we're going to be doing this semester, because the rest of the year, all we're doing is hypothesis tests and confidence intervals. That's it. We're not doing anything else. So you need to go find something called a one proportion. Specifically, it's called a one proportion Z test. So on my calculator is the number 5 option here. So again, remember, I went to Menu, Statistics, Stat Test, one proportion Z test. Go there. Okay, now here's how it works. P0, that's your null hypothesis. We are assuming for number 1, the one we just did, we're assuming that 35% of teens are in a relationship or have experienced dating. So 0.35. X and N, X is called the successes that come from your sample. So remember that in our sample of 100 teens, 25% of them are in a relationship. So that means that there's 25 people out of 100 who have experience in dating. So you would put X would be 25, which is your number of successes out of the 100 that you sampled that have experience dating. The alternative, you can change this depending on what the scenario was. If you wanted to increase, you would go with greater than. If you wanted a decrease, you would go with a less than. This question just asked, is there a change? So you go with the not equal to. Press OK. And then what it's going to give you is going to give you the test statistic and the p-value.
Mine gave me a domain error.
Because you didn't follow it right. Here, let me just show you one more time. You go to Menu, Statistics, Stat Test, one proportion Z test. You get to type in 0.35 for the P0. X is the number of successes. So that's not going to be a decimal. That's going to be like 25 people out of 100. You have to put 25 people out of 100. And then that should give you the right thing. Okay, so one more time. Here we go. It tells you the Z, which is your test statistic, and it tells you the p-value. So remember, we did those already, negative 2.09. And the p-value here, it's already been multiplied by 2, so you don't have to worry about it. So just to save you time, or just to, usually I like to use this just to confirm that I did my results correctly. I always like to do it first by hand, like I showed you. And then I use this function to verify that I did my p-value right and my test statistic right. So that's how you can do it. So now you know how to do that. So number 2, use the calculator and make sure you know how to use that. Okay, let's also recall in chapter 18, I forgot to show you, I guess because I didn't have time, those confidence intervals that we made on chapter 18 can also be done with the calculator. So let me show you one that's on your note. Number 3, we already did this a long time ago, but it said, suppose that we take a sample of 80 students and find that 54 of them are wearing contacts. Make a 90% confidence interval for the true proportion of students who are wearing contacts. So let's try to do that on the calculator. Obviously, I already taught you how to do like the formula, the substitutions, and how to get the answer like the long way. But on the calculator, there is a function to do it quicker. You go to Menu, Statistics. It's called confidence intervals. And again, these are all the confidence intervals that we're going to do the rest of the year. The one that we just did the chapter 18 is called a one proportion Z interval again. So for the test, we are doing one proportion Z intervals and one proportion Z test. So click on that one proportion Z interval. And it works the same way. This time it wants to know the number of successes out of your sample size. So I guess if we're doing 54 of them out of 80 were contacts. Well, that's what I'm going to do, 54 out of 80. And then If it wants 90% confidence, you just type 90% confidence right here. You don't have to like add the bottom tail or anything. It automatically does that for you. So if it says 90% confidence, just make sure you use 90% confidence. And right here where it says lower and upper, those are your lower bound and upper bound. So you, again, I would still recommend like you do like show the formula, show the substitution, especially on the AP exam for sure. Show the formula, show the substitutions, and then you can just use this for the calculation part. The only thing you have to be careful with these things is that error that Raj got is called a domain error. So let me show you why. Let's try letter B. In a May 2000 Gallup poll found that 38% of a sample of 1,012 adults said that they believe in ghosts. Find a 95% confidence interval. So this is going to give us a domain error if we type it as is, because let's just go through it. Okay, let's go find the menu, statistics, confidence interval. The number of successes, you're supposed to take like your sample size, 1,012, times 0.38, and then your sample size is 1,012. Okay, but here's the and then what was the confidence interval? 95%. But here's the problem. If your number of successes, so the 1,012 times 0.38, if that's not a whole number, then it's not going to work. Like if I do it here, it didn't even tell me something. It's supposed to give you an error. Did it give y'all an error? 1012 times 0.38. 1012. Okay. Oh, there we go. It's called domain error. And that's because when you do 1012 times 0.38, that's not a whole number. So if you do want to do this question, you do need to round your number of successes to a whole number. And you can just round to the nearest whole number. Either up or down, just round to the nearest whole number. So according to my calculations here, 38% of 1,012 is 384.56. So let's round to 385. So if I go back and do my interval, this time I'm going to use 385 for my number of successes. And then it will work. And that was the answer, 35% to 41% that believe in ghosts or whatever that was. But that's how you use the calculator for intervals and tests. Practice that as well. Okay, I'm going to stop my recording and then answer questions. So remember, your homework is to do this review sheet, because that is for a daily grade, and submit your answer here. Let me stop.